Lagrange. Now, we have this function here, f of x equals sine of 5x plus pi over 3. And we want to write a third degree polynomial to approximate about x equals 0. So n is equal to 3 here. So we know we're going to take 3 derivatives. So my function is the sine of 5x plus pi over 3. Its derivative, very easy to do, chain rule, we get 5 cosine 5x plus pi over 3. Our second derivative, chain rule again, but this time we get negative 25 sine 5x plus pi over 3. And the value of our third derivative, we're going to get negative 125 cosine 5x plus pi over 3. Now, to get my polynomial, we have to find the value of each derivative at 0. First one's pretty easy. It's just the sine of pi over 3, which is root 3 over 2. Cosine of pi over 3 is 1/2, but I'm multiplying it by the 5, so I get 5 halves. Here, we're going to get this negative root 3 over 2, but we'll multiply it by negative 25, so negative 25 root 3 over 2. And the last one, we're going to get this 1/2 again, but negative 125 over 2. Remember, to get our Taylor polynomial is the value of the nth derivative at c over n factorial times x minus c to the n. So if I want to write my third degree polynomial, we're going to start up here. N is 0, so we get root 3 over 2. Plus, don't worry about all the x's because they all just become these 1 and 1. So I get 5 halves. Again, I'm dividing it by 1 factorial, so that's not going to change anything. And this becomes x minus 0 to the first, or just x. Minus, this alternating now, I get 25 root 3 over 2, but I'm on my second derivative, so I divide that by n factorial. And again, this just becomes x squared. Again, I don't have to write the 0 down if I don't want to, right? That can just go away. We don't need the 0. Then the next term, minus 125 over 2. But again, that's my third derivative, so I divide that by 3 factorial, and I get x cubed. And there is our third degree Taylor polynomial right there. Now the next question we're asked is to use the Lagrange error bound to show that our error is less than 1 over 1200. Well, just like when we did alternating series, we're really trying to show that the remainder of the third term, in our case, is going to be less than the next term. The problem is we don't know this. We don't know. So we're always looking for the next term. So what Lagrange says, well, to get the maximum value of the next term, the max value of the next term, he just used the Taylor polynomial itself. He said to get your error, it's going to be less than the absolute value, positive, of f of n of z, we'll talk about that in a second, over n factorial times x minus c to the n. Well, all these we kind of know. We know, for example, for us, we're looking for the remainder of the third term. It has to be less than the value of the fourth term, derivative, over 4 factorial. And again, c for us is 0, so this is just x to the fourth. So this is how we can get our remainder. It has to be less than the value of the next term from Taylor itself. We're getting it from Taylor series. The problem is this f4 of z. This is the maximum value of the fourth derivative. So we need the fourth derivative. So to get the fourth derivative, I come up here and I'm going to get this. Using chain rule, we're going to get, what is that? 625 sine of 5x plus pi over 3. So how can I use this to get my maximum value? Therefore, we can say the maximum value the maximum possible value. If you think about it like this, ready? We're going to get this very simple. Well, the max value this could be is 1. It's a sine function. So the maximum value all of sine can be is 1. So what does that make for my maximum value? This, therefore, if we take that 1 times 625, the most we can be off is by 625. So this is going to be less than or equal to 625. So therefore, this is my max possible value of the fourth derivative. And I'm going to use that in my formula. So to get my remainder, R of 3, sub 3, this is going to be 625 over 4 factorial times my x. Now, what's my x value? That's up here. There's x. So we know x is 1 over 15 to the 4th. An absolute value of that. And if you do a little bit of manipulation, this was not too hard to do. Ready? And if you want to do this, this is kind of cool to do. Ready? If I go off to the side here, I'm going to go off to the side here. 625 over 4 factorial times 1 over, basically this is 15 to the 4th. And really cool algebra, 625 is 5 to the 4th over 4 factorial times, this is 1 over, oh look, 5 to the 4th times 3 to the 4th. Those cancel. And I get 1 over 4 factorial times 1 over 3 to the 4th. And using quick calculation, this is just 1 over 24 times 1 over 81, which is 1 over 1944. Which is less than this 1 over 1200. Less than or equal to that 1 over 1200. Therefore, the value of my next term, the most I can be off, this is the most we can be off by Lagrange, is less than 1 over 1200. So therefore, by Lagrange error, we know that our error will be less than 1 over 1200. So I'll see you guys later. All right, bye-bye.